Let's take a look now at perpendicular lines. So again, we're dealing with slope. The change in y over change in x, which I actually like to use rise over run. And we did use this formula the last little bit in order to find our steepness or our slope. Of course, the other way to find our steepness or our slope is to look at the graph. And so the idea here is examine the following perpendicular line segments and find their slopes. So they're already telling us that these are perpendicular. Now let's actually hope that they are. So I'll deal with 1, and we'll do rise over run. So 1, 2, 3, 4. That's my rise. So my rise is up 4. Remember, I started on the left dot, and that's always what I'll do. And then 1, 2, 3, 4, 5, 6, 7, 8. So 8 to the right. So a positive 8. And we can reduce that fraction to 1 over 2. Just trying to zoom in here. 1 over 2. Okay, so that's the slope of this. Now let's compare that to starting on the left. For line number 2. So that's right, it's right here. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going down 8. So I'll put minus 8. And I'm going right. 1, 2, 3, 4. So I'm going right by 4. So 8 and 4, those are the numbers I had before, but this time when I reduce it, I get those both can be divided. So negative 2 and 1. Okay, so what do we notice between these two lines? These two slopes. Well, the fractions are flipped upside down from each other, and one of them's positive and one of them's negative. Okay, well, let's take a look and see if that pattern exists for the next one. Okay, so let's continue on here for B. Notice my program did switch a little bit because I've changed things. Hopefully this won't crash, but we'll take a look. Let's deal with 1. So this is line number 1. I'm going to use the left as my starting spot. So 1, 2, 3. So my rise is up 3, so positive 3. And I will go to the right now. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go positive 9. And that can be reduced to divide both by 3, so 1/3. Now let's take a look at number 2 here, and this line. And I'm going to start on the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going down by 9, so minus 9. And then 3 to the right. And sure enough, if I divide those by 3, I get negative 3 over 1. And again, those fractions are flipped of each other, as well as one's negative, one's positive. So yes, it looks like perpendicular lines are flipped fractions of each other, and one's positive, one's negative. So let's take a look at C just to confirm this one more time. I'll start with line number 1 here. Start at the left, so I'll go here, and I will go 1, 2, so up by 2, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to the right, so positive 10. Which reduces to 1/5, positive 1/5. And let's take a look at line number 2 here. And I will start up here, and I will go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like 10 down. So minus 10 is my rise. And I'm going to run 1, 2 to the right. So if I reduce that, I'll get a negative 5 over 1, and that's it. Again, we can confirm that, yes, the fractions are flipped of each other and one is negative. So that's how you're going to tell if lines are perpendicular. Look at two different steepnesses, two different slopes. Check to see if they're flipped fractions and that they're opposite signs. So what we call that, by the way, is negative reciprocal. Reciprocal meaning flipped, and negative is one's negative, one's positive. Okay, so this one says, example 2, graph each pair of line segments and determine if they are perpendicular. So I'm assuming that these two will go to make one line, and these two, usually it's A and B is together, and then C and D. So you should know how to read these by now, how to plot graphs. Just as a reminder though, then you can go 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, 5, that sort of thing. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. And so we're going to deal with some x direction and some y direction. And the first one is x, the second one is y. So for a here, it tells us to go -4. That's going to be left by 4 because it's negative. So here, and then up 3. So that's going to be our A. And our B is left 2, down 5. So you can connect those dots. That's our A, B. Now our CD, so there's C. C is -5 in the x direction and -5 in the y direction. So -5 in the x direction and then -5 in the y direction. That is C. And D is +3 in the x direction and then -3 right there in the y direction. So I mean, perpendicular lines would be ones that look like that have a 90 degree. So is that 90? Well, the only way to tell is to take a look at my slope. So you could do this algebraically with y2, y1. Y2, y1 over x2, x1. Or did we do yb minus ya? I think that's what we did. Over xb minus xa. But we like to do the faster way, which is just looking at the graph. 1, 2, 3, 4, 5, 6, 7, 8. So down 8 and 2 to the right. So that would be a -4 over 1 once we reduce that. Both could be divided by 2. Now with my C here, with this line, I have a rise of 1, 2, so +2. And where's my, there we go. And then 1, 2, 3, 4, 5, 6, 7, 8. 8 to the right. So that can be reduced to 1/4. So are these perpendicular? They're both flipped and one's negative, so the answer is yes. So let's continue here, taking a look at B here, A, B, and C, D. So A is going to be -5. So 1, 2, 3, 4, -5 and 3. So you should get pretty familiar with where to plot these things. B is +3 in the x and down 5. +3 in the x and 1, 2, 3, 4. Oh, great. +3 and 1, 2, 3, 4, 5. So that's B. So there's our line AB. You should probably use a ruler. That looks terrible. C is going to be -3, 1, 2, 3, and -4. 1, 2, 3, 4. That's our C. And our D is over 5. 1, 2, 3, 4, 5, and up 3. So is this perpendicular here? I mean, my lines are really off. Turns out, by the way, yes, this was. We said yes. So we can put that little symbol there, but I don't know if B is. So let's do the slope. We'll start with line AB here. 1, 2, 3, 4, 5, 6, 7, 8. 8 down, and 1, 2, 3, 4, 5, 6, 7, 8. Right. Okay, so we have 8 down, so -8, and 8 right, so that's going to be a +8. So -8 over +8 is just going to be a -1 over 1. You don't even need to write that one. You could just write -1. Okay, let's take a look at CD. So I'm going to do C here. 1, 2, I was going to use the red here. 1, 2, 3, 4, 5, 6, 7, 8. Nope, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, 7. And then 1, 2, 3, 4, 5, 6, 7, 8. So I have up 7, and then I've got right 8. So that's a positive. Positive is up, and positive is right. So 7 over 8 is my answer, and that is not the same as 1 over 1. So the answer, of course, is no. It's not. So we can't put this symbol there because it's not perpendicular. Now, C is requiring us to use algebra. So as a reminder, we're going to label these things. Hopefully, I can give you some more space here, actually. Hopefully, yours does look a little different. I will label this one right here, X1. No, what did we use? No, I'm just going to double check up here. We used A and B. Okay. So we're going to call this X and Y and X and Y. And we'll call one of them A and A, and the other one B and B. and we'll find the slope of that. So for our AB slope, MAB, our slope for AB, we can go YB, which is 4. Remember, the formula is YB minus YA over XB minus XA. That's what we are doing for our slope. So YB is 4 minus YA is negative 1. Now XB is 5 here, and XA is negative 5. So we're going to minus, and then we're going to minus a negative 5. Okay, well, that will be a plus, and that'll be a plus. So 4 plus 1 is 5. 5 plus 5 is 10. So those can be reduced to a half. Okay. So now we can do the slope for CD. So we can go ahead and label again. I'm going to use the same things. XA and YA, XB and YB. So I have to start with YB. So YB here. YB is negative 6 minus YA, which is 4. And then XB, which is 3, minus XA, which is minus 2, or negative 2. So top negative 6 minus 4 is going to be a negative 10. And 3 plus 2 is 5. That reduces to negative 2 over 1. So is this perpendicular? Are these steepnesses, are these slopes perpendicular to each other? And the answer is yes. They are flipped fractions from each other, and one is positive and one is negative. So you could write that right here. You could write, okay, this one's a half. This is negative 2 over 1. And so yes, it is perpendicular.